All right, let's dive into a question that seems to break one of the most fundamental rules of physics. It's a cosmic riddle, really, one that pits the age of our universe against its absolutely staggering size. And trust me, the solution is going to change the way you picture everything. Okay, so let's start with a number we know for sure. Thanks to some incredible science, like measuring the faint afterglow of the Big Bang, we've nailed down the age of the universe to about 13.8 billion years. That's our starting point. That's our timeline. But, and this is the big but, the diameter of the part of the universe we can actually see, our observable universe, is a whopping 93 billion light years. So wait a second, if nothing can go faster than light, and the universe is only 13.8 billion years old, how on earth did it get so big so fast? And that is the million-dollar question, isn't it? It feels like a total paradox, a cosmic glitch in the system. But as we're about to find out, the answer reveals something truly mind-bending about the very fabric of reality. So how do we untangle this knot? Well, the very first step is to get super precise with our words, starting with what we actually mean when we say the universe. Okay, so first up, let's define our little cosmic bubble. This isn't the entire universe we're talking about, not by a long shot. It's just the part that is, visible to us from here on Earth. Think of it like our personal cosmic horizon. It's not a physical wall or an edge, but a boundary in time. We can only see the light from objects if that light has had enough time, 13.8 billion years, to travel across space and finally reach our telescopes. Anything beyond that horizon? Well, its light just hasn't gotten here yet. And this chart right here just lays the problem out so clearly. The universe has been around for 13.8 billion years, but the edge of our observable bubble is a staggering 46.5 billion light years away from us. How did that happen? Well, it's time to reveal the secret ingredient. Now, it's really important to remember, this isn't just guesswork. These numbers come from real hard data. We're talking about information from the Hubble and James Webb telescopes, data from the Planck satellite mapping that ancient cosmic light, and it's all built on the framework of Einstein's general relativity. This stuff is solid science. So what is the secret ingredient? The answer to this whole paradox isn't that things are moving through space faster than light. That's impossible. No, the answer is about space itself. This right here is the key that unlocks everything. Nothing is breaking the speed limit. Instead, the very fabric of space-time itself is stretching, it's expanding. And the galaxies, they're just being carried along for the ride, kind of like dots on a cosmic conveyor belt that's getting longer every second. The absolute best way to visualize this is with the classic balloon analogy. Just picture it. You take a balloon and draw two little dots on it. Now, those dots aren't walking around on the rubber surface, but as you blow up the balloon, what happens? The rubber itself stretches, and the distance between the dots gets bigger. That's exactly what's happening in our universe. So think about some super distant galaxy. When it first sent out the light that we're just now seeing today, it was actually much, much closer to us. But in the 13.8 billion years it took for that light to travel to us, the space it was moving through was constantly stretching, adding billions and billions of light years to its journey. Okay, so we've solved the riddle of our 93 billion light year bubble. But what about everything else? What's lying out there beyond the edge of what we can see? And this, my friends, is where things get even more mind-boggling. So now we have to make this really critical distinction. Everything we can see, everything we've measured, is inside our observable bubble. But that little bubble is not the entire universe. Now, what's really interesting about this slide is how it breaks down what we know versus what we can only guess at. Our observable universe, we've measured it. We have a pretty solid number for its size. But the entire universe, we have no idea. It could be finite, or it could literally go on forever. That's one of the biggest mysteries out there. And just to try and give you a sense of scale, some scientific models suggest that the entire universe is at least 250 times bigger than the part we can see. And folks, that's considered a conservative estimate. The reality is it could be trillions of times larger, or just infinite. So after all of that, what's the big takeaway? How does solving this cosmic riddle actually change our perspective on things? Here's what it all boils down to. Everything we've ever seen, every star, every galaxy you've ever seen a picture of, all of it exist inside our tiny observable bubble. But that bubble is just a small, brightly lit island in what is likely a vast and possibly endless dark cosmic ocean. So yeah, we figured out why our cosmic bubble is 93 billion light years wide. But in doing so, we've stumbled upon an even bigger question. If our universe is just one tiny patch of a much larger reality, what else is out there? What incredible things lie waiting just beyond the edge of our vision, in that unimaginable darkness? Well, that's a question for another time. Thanks for joining me.